episode of M&E Labs, an online platform where we discuss some of the basic and fundamental concepts on monitoring and evaluation analytics for the beginners. So today, as you can see, we are going to discuss the sample size. So I've heard, a lot of people suggesting, okay, let's take 10% of the population, that will be the right sample size. Let's take 20% of the population, that will be the adequate sample size. That's not right, actually. That's a myth. Because there has to be some science behind the sample size that is chosen. So there is a simple formula that is used to collect the sample to arrive at the sample size, right? And it depends on the objective of the study, right? So because there are many formulas that are used to calculate the sample size, so the objective of the study is really important. So for example, if your sole interest is to have one-time description of prevalence rates, so one type of sample size is used. So this is called one sample formula. And let's say you want to look at two proportions, right? Before intervention and after intervention, pre-post kind of a design. So there a different sample formula is used. So, power, etc. is incorporated there. So let's start with the simpler one. So the one sample formula. So today we are going to deal with one sample formula. So the formula for this is very simple. N is the sample size that I want to arrive at, that I want to calculate. D into Z square into P into Q upon E square, right? Right? Now let's understand what these symbols are. We'll discuss about D later on. Let's look at the simpler thing. To calculate the sample size, we have to first decide what is my confidence level. Mostly in social research methods, we go by 95% confidence, right? Okay. So Z is the Z value of 95. So if you look at, go to Google or you look at your textbooks, statistics textbooks, it gives you what is the Z value, for particular confidence levels. So for 95%, the Z value is 1.96. It is already been calculated and defined. So it can simply be used, right? 1.96. Now, the second thing that as a researcher we have to decide in advance is there, what is the permissible error? What is the error that I want to consider, maximum error that is allowed? Mostly for research, social research method, we go with 3% or 5% error, right? So error, if it is 3%, so 3% is basically what? 0.03, right? 3% is 0.03, no? You understand this, no? So 3% is basically 3 upon 100. This is equal to 0.03, right? So error is 0.03, right? Now P is basically the baseline, proportion or the current prevalence. Okay. So for instance, let's say we are doing a study. Listen this carefully. We are doing a study which is a communication needs assessment. Right, where this organization is wanting to develop a short video, short film on family planning methods for women, right? So the objective of this study is to understand the communication needs. The medium that is to be used is television, and the target audience or the target population is the women. Let's say women in the reproductive age group, right? So who do we go and reach out to? We cannot just go and talk to any boy, girl, man, woman, right? So as we said, this communication is a communication campaign targeted to a particular cohort of women, which is the reproductive age group women, and it's on family planning. So and the communication will be aired through television. So my objective would be to reach out to the households that has television, and women under the reproductive age group. So let's say, for instance, we just see what is the proportion of television ownership in that particular geography. Let's say this communication is to be carried out in Bihar. Okay, so first what we'll have to understand is what is the penetration of television or ownership or viewership of television among women. So you refer some literature and you get to know that 40% of the rural women in the reproductive age group, they watch television, right? So the P is 40%, right? Now what is 40%? Again, 40 upon 100 is 0.4, right? Okay, that's clear. So P is 0.4. Q is nothing but 1 minus P. You know P. So Q is 1 minus P, which is, what is this? Please use your calculator. 0.6, right? That's clear. So we know this value, we know this value, we know this value, we know this value. Now what is this thing called design effect? D is the design effect, right? What is a design effect? Why do you even need a design effect, right? So this is basically for a simple reason that whatever sample size this gives you, we as a researcher, we want them to be unique samples, right? What happens if there is very high correlation between two samples? The responses will appear to be very similar, right? If two samples, let's say, for instance, you are coming to me, talking to my twin brother living in the same household, we will be responding very similar, right? So for your research purpose, would you consider us as two sample? No, right? Because we are so similar. We are very highly correlated. So the objective is to minimize, to factor in this also, that there is a possibility that within a cluster there will be some correlation between the samples that you are covering, right? Which is called intra-class correlation, right? Now the formula to calculate this is 1 plus rho into n minus 1, right? And this is the intra-class correlation. We assume in our social research methods, this intra-class correlation is 0.02, meaning we go by the assumption that they are not highly correlated. Do you remember the correlation? Correlation is, if it is highly correlated, it will be towards 1. If it is very low correlated, then it is close to 0, right? So we are going by the assumption that there is some correlation, but there is not huge amount of correlation, right? So and then n is the sample that I choose from each cluster. So for example, cluster is, let's say, the village that we are going. So in a particular village, we are thinking of covering 20 households. So n is 20, right? So 20 minus 1. So this is equal to 1 plus 0.02 into 19. This is equal to 1.92 is 38. So 0.38, 1.38. So the design effect is 1.38. So we have gotten this value also. The D is equal to 1.38. Yeah. Now we have all the values. All we need to do is fit them into this formula. Using this example where I am looking at 95% confidence level with 0.03 error margin. My P is 0.4, Q is 0.6, my design effect is 1.38. What will be the sample size? Can you just quickly do this calculation yourself and tell me? I am also doing this calculation. So 1.96 square is 3.84. So this is, we are just replacing this value, right? 3.84 into 0.4 into 0.6 into 1.38. Now error 0.03 whole square is equal to 0.0009. 0.0009. Yeah. Now let's do the rest of the calculations. 1.38, this is 1.38 into 3.84 into 0.4 into 0.6. This equals 1.27 upon this divided by 0.0009 is equal to 1430. So we round it up to 1420. So for this, in this example, for confidence level of 9, Z 1.96, error 0.03, P 0.4, Q 0.6, design effect of 1.38, this is the sample that you would be requiring, right? So where you know the proportion, like say, for instance, here it was relatively easier because we can get through secondary sources what is the penetration or TV viewership amongst the our target group. But there may be some variables for which we do not have any idea. Okay, like for example, access to a particular service. Okay, let's say access to a particular scheme, government scheme. Let's say we don't have that data. So in case where we don't know the P, we very safely take it as 50% or 0.5. By using this, you get the highest sample size. Yeah. So where you don't know the P, you can safely use 0.5 and then you will get your required sample size, right? So I hope this was a useful session for you, and now you should be able to calculate the sample size where your objective is to understand one-time prevalence rate. So thank you very much for watching this video, and keep watching for the further similar videos.